Every year, parts of the planet are hit by devastating typhoons and hurricanes. They can cause billions of dollars of damage and take hundreds, if not thousands, of lives. But why do these storms exist? What causes their distinctive spiral shape with an eye in the middle? And why do they only appear in certain parts of the world at certain times of the year? And while we're at it, what's the difference between a hurricane and a typhoon anyway? Learn more about hurricanes and typhoons and how they can become so deadly on this episode of Everything Everywhere Daily. Let's start this discussion with the easiest question to answer. What's the difference between a hurricane and a typhoon? The answer is that they're the same thing. They're just different words used in different parts of the world to describe the same phenomenon. Both hurricanes and typhoons are classified as tropical cyclones, which are storms with a wind speed beyond a set value, and more on that in a bit. A hurricane is just a tropical cyclone that forms in the Atlantic Ocean. Almost every hurricane forms north of the equator, usually around the Caribbean or the Gulf of Mexico. There has only been one recorded hurricane-force tropical cyclone in the southern hemisphere. Hurricane Katrina, not to be confused with Hurricane Katrina, was a Category 2 hurricane that hit the southern coast of Brazil in March of 2004. A typhoon is a tropical cyclone that forms in the Pacific Ocean north of the equator. These will usually form near East Asia and will frequently hit the Philippines, Vietnam, China, and Japan. Tropical cyclones, which are south of the equator in the Pacific Ocean or that form in the Indian Ocean, are just known as cyclones. So, hurricanes, typhoons, and cyclones are all the same meteorological phenomenon. Europe and Antarctica are really the only continents that are immune from tropical cyclones, as they're not in the tropics. Occasionally, a hurricane might make its way far enough north to reach Britain, but by that time it would just be a tropical depression at worst, or just a plain old rainstorm. In addition to the different names, one of the confusing things about these storms is that there are different systems to categorize them all over the world. It seems like something that would really benefit from a global standard, but one hasn't developed. There are 5 different intensity scales based on wind speed that are used in different parts of the world for tropical cyclones. The best known for most of the listeners of this podcast would be the Sapphire-Simpson scale, which is used for storms in the Atlantic, as well as the Central and Eastern Pacific. This is the system that ranks hurricanes from Category 1 to Category 5, with tropical storms and tropical depressions below that. There is another system used in East Asia, one in India, a French one used in the Southwest Indian Ocean, and another one used in Australia and Fiji. In the Northern Hemisphere, the season for tropical cyclones is from June to November, although rare storms have appeared in both May and December. In the Southern Hemisphere, the season is usually from November to April. Due to geography, there are more tropical cyclones in the Northern Hemisphere than in the Southern Hemisphere. The location of land masses and ocean currents leads to more storms forming north of the equator. Tropical cyclones almost never cross the equator, and I'm just hedging my bets by saying almost never because one has never been observed to actually do that. In fact, almost no tropical cyclones form within 5 degrees north or south of the equator. The lack of cyclones near the equator is due to the Coriolis Effect, and again, more on that in just a bit. So the big question is why these storms form and what makes them so powerful. It all starts with warm water. This is why tropical cyclones are tropical. The tropics is the area between the Tropic of Cancer in the north and the Tropic of Capricorn in the south, where the sun hits the Earth at its most direct angle. Each tropic line is 23 degrees 26 minutes above or below the equator, which is exactly the same as the tilt of the Earth. For a tropical cyclone to form, ocean water must have a temperature of about 80 degrees Fahrenheit or 26.5 degrees Celsius. For a cyclone to sustain itself, this temperature usually has to exist in the top 50 meters of water. When the water temperature gets this warm, it starts to evaporate on the surface and rise into the air. This warm, wet water will rise until it hits the troposphere, where it will cool and precipitate out as rainfall. The rising hot, warm air causes a low-pressure region near the surface of the water. The higher pressure air around the lower pressure region flows into it, where it will then rise up. This low pressure is really the engine behind a cyclone. A low-pressure region with surrounding high-pressure regions will continue to drive warm, wet air up and send it back down in the form of rain. One other condition is that there can't be too much wind in the upper atmosphere. If there's too much wind shear, the entire system can blow out like a candle even before it gets started. However, there's obviously more to these storms than just that. These storms spin and move. What causes that? The other thing that causes tropical cyclones is the aforementioned Coriolis Effect. For all practical purposes, we cannot experience the rotation of the Earth by just standing on it. However, the Earth does spin faster at the equator, just like how a record will move faster at its edge than it does in the center. The rotation of the Earth does affect air in the atmosphere. Because air at lower latitudes is moving faster than air at higher latitudes, wet air will start to rotate as it moves to the low-pressure region, conserving the angular momentum of the air. In the northern hemisphere, all tropical cyclones rotate in a counterclockwise fashion, and in the southern hemisphere, they all rotate clockwise. The Coriolis effect also explains several other things. The reason why no tropical cyclones form within 5 degrees on either side of the equator is that the Coriolis effect is minimal there. Water can still evaporate, but it just becomes a rain cloud. Likewise, it's almost impossible for a tropical cyclone to cross the equator for the same reason. If it did cross the equator, it would have to reverse its spin, and the storm would just collapse. If you look at a map of all the tropical cyclones in the world, you will see a band right along the equator with nothing, and then storms above and below the band. Due to the Coriolis effect and the rotation of the Earth, tropical storms will always travel east to west, and then will usually wander to the north or the south, depending on what hemisphere they're in. As the storm develops, a low-pressure region in the center can become very pronounced, and this is known as the eye of the storm. The winds in this region are rather calm, and this region actually starts to pull cold air down from higher pressure regions above. Immediately outside the eye is the eye wall. This is the region of the storm with the highest wind speeds. While the high wind speeds from a tropical cyclone can be extremely dangerous, the greatest damage can actually come from the storm surge. A storm surge is a type of flood where the high winds of the storm blow water into the shore. The highest storm surge ever recorded was in Australia in 1899, when a storm surge of 44 feet or 13.4 meters was recorded. The magnitude of a storm surge depends on the storm's wind speed, the shore's orientation to the storm, and the tides. A storm surge that happens during a high tide is known as a storm tide. This low-pressure, high-pressure cycle can keep driving a storm so long as there's warm, wet water to keep fueling it. However, a tropical cyclone will eventually die, but how it dies will depend on what it runs into. If a storm runs into land, it will be deprived of warm water, dying out and eventually just becoming a rainstorm. If a storm is in the middle of the ocean and veers north or south, it will eventually hit cold water or drier air, which will also kill the storm. There have been several tropical cyclones that have been incredibly destructive. One of the strongest storms in history was the 2015 Hurricane Patricia. It had the highest wind speed ever recorded in a tropical cyclone at 215 miles per hour or 345 kilometers per hour. And it also had the second lowest pressure ever recorded at 872 millibars. The lowest pressure ever recorded was in Typhoon Tip in 1979 with an 870 millibar reading. This was also the lowest atmospheric pressure ever recorded on planet Earth. The deadliest storm in history was the 1970 Bolha cyclone, which hit Bangladesh in India. Over 500,000 people were killed on November 12, 1970. One of the recognizable features of hurricanes in the North Atlantic are the names given to them. In the early 20th century, meteorologists had a complex naming system for every storm based on the latitude and longitude of where it originated. During the Second World War, Army meteorologists in the Pacific began to give storms women's names to make them easier to remember. The system worked so well that in 1953, the National Hurricane Center began using the same system for Atlantic hurricanes. The storms are named in alphabetical order, so the first storm begins with A, the second with B, etc. Eventually, they had a hard time coming up with women's names every year, so in 1978, they began using men's names for half the storms. A storm name tends to be reused every 6 years, as there is a 6-year rotation of names. But starting in 1979, if a storm was particularly devastating, which is decided by the World Meteorological Association's Hurricane Committee, then its name is permanently retired. As of the time of recording, 95 hurricane names have been retired. The season with the most retired storm names was 2005, with 5: Dennis, Katrina, Rita, Stan, and Wilma. Other naming systems are also used by other countries, including Japan, India, and the Philippines. Hurricanes and typhoons are the most powerful things on Earth. Factoring in all the wind, rain, and lightning, an average hurricane has enough energy as 200 times the entire energy consumption of the planet. They expend more energy than a volcanic eruption and all but the most powerful earthquakes. Hurricanes and typhoons are a fact of life in many parts of the world. They are awesome events that are worthy of respect. Everything Everywhere Daily is an Airwave media podcast. The executive producer is Darcy Adams. The associate producers are Thor, Thomsen, and Peter Bennett. I just wanted to extend a big thank you to everyone who is supporting the show over at patreon.com. I have show merchandise available there, including hoodies, t-shirts, and stickers. Plus, it really just helps me get this show out every single day, including, of course, weekends and holidays. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.